And that is different to intensity, because if we are working with an athlete or any individual, the intensity is a function of the load at which we're working, the external load at which we're working. In other words, if I have an athlete working at 180 watts on a bike, what is that intensity? Well, that intensity is linked, let's just flick back to those internal characteristics. What we try to do in terms of working in, particularly in high performance sport, is we try to marry up the external load with the internal load in relation to the intensity we want them to be operating at. Clearly, if I've got an athlete working at a low intensity, that will probably manifest itself in terms of a low internal load and may be seen with a low lactate concentration or low heart rate response. So this is some data that was published actually quite a while back now, but it's really nice. This is on the Sports Science website, and this is from Steve Seiler's group. And what you've got here is some data that he's taken for some elite Norwegian athletes. And what makes this really quite interesting is that the data set that we have here allows us to see two kinds of sessions. So you've got here a 50 to 90 minute session compared to a 24 to 30 minute session. Now, what they don't tell us here really is the fundamentally important thing, which is, well, how intense are these? Now, one could probably make a case that this session on the right in the kind of the pink box is more intense. Why? Well, one, the duration is shorter. That's not what is a prerequisite, but generally if the duration is shorter, it allows the intensity to be higher. But also we look at kind of the reps that are being run. It'd be unusual if these were just lower intensity reps compared to these. Remember that, you know, if the duration is longer, the intensity is generally lower. So we can make an assumption here about the intensity. What we would want to do, though, working with coaches and sports scientists, we want to be certain in terms of the intensity which we're prescribing. Although we've got 6x5 minute runs, we need the athlete to know how intense that should be. In other words, what internal load are we trying to generate? Because that dictates what the biological or the physiological, morphological response is that we're trying to induce. And the same can be said here. So here we've got another session from the Steve Seiler paper, and the same thing can be applied. So we can see that the different sessions that they've asked the athlete to do, they've got two on these different days here, in these sessions here. But what you can again see is there is no evidence, I've blanked it out, there is no evidence here that we're showing you, or I'm showing you, in terms of how intense these sessions are. And you suddenly understand that without an understanding of the intensity, the training becomes almost pointless. Because remember that the fundamental driver of biological adaptation is exercise intensity. It is the primary stimulus for biological adaptation. So, for example, yeah, I could prescribe 7 by 1,000 meter reps of 90 seconds recovery, but how does the athlete know at what intensity to run them? Are these meant to be efforts which are VO2 max orientated efforts? Are they meant to be efforts which are around the gas exchange or the lactate turn point? Are they meant to be efforts which are below gas exchange threshold in the moderate domain? Because wherever the athlete performs those will change the response that they produce, the biological response. It will change the internal load that's being applied, and therefore it will change both the acute physiological response and then, you know, if that's kind of magnified over time, the chronic biological adaptation that they develop. So intensity becomes really important to us, and therefore we start to understand why we have to be able to prescribe intensity precisely and monitor it precisely if it fundamentally, as we've said, is the driver of biological adaptation. So we come to Steve Seiler's work, and this is, again, really neat for us to understand. So he writes this: to describe intensity distribution in endurance athletes, we have to first agree on an intensity scale. There are different intensity zone schemes to choose from. Most national sport governing bodies employ an intensity scale based upon ranges of heart rate relative to maximum and associated blood lactate. And this is absolutely the case. These are the internal loads which are plotted against the external load, which in the case of sport will be things like speed for running, wattage for rowing or cycling. And so we're looking for that association, and from those we can then identify how intense the exercise is. When we anchor those biological responses to our understanding of systems physiology. And so this is really where our journey within the rest of this class is going to go to. So when we think about endurance physiology, we understand that these are the traditional parameters that we have to think about. That when we think about endurance, the athlete, a good endurance athlete has to be highly economical. They have to have, they've used the term lactate threshold here. I'm going to use the term throughout the course of this lecture or this class of lactate turn point. They fundamentally mean, or we mean the same thing, which is the systemic increase in blood lactate, the point where the lactate concentration shows the exponential rise against the external load. Then there is the critical power. The critical power represents the boundary between heavy and severe exercise domains. Now, if you're unsure about what this is, and also if you're unsure about economy and lactate, there are additional classes within this YouTube channel where you can learn about economy and you can learn about lactate responses. And then the upper ceiling in terms of endurance is the VO2 max, the maximal oxygen uptake. All of these as parameters are then linked to these kind of biological characteristics, so the rate at which one uses carbohydrate, the rate at which one stores heat or dissipates heat, the rate at which the anaerobic capacity is used, because this is quite important when we think about training, particularly when we start to move beyond lactate turn point, or as they've dictated here, threshold, and really once we go beyond critical power, the anaerobic capacity is used incredibly rapidly, and that is a finite reserve. And then, of course, the byproduct of that is metabolite accumulation. You take them as a whole, and they're linked to exercise tolerance. At any exercise intensity, our ability to tolerate exercise is a function of where we sit on this schema here, where we sit from lower intensity exercise, which would be below this point here, what we term moderate, when we sit between threshold, as they've dictated here, and power and critical power, which is heavy, and then if we sit beyond critical power up to VO2 max, which is what we term severe. All of those dictate these biological responses that you see here and our ability to tolerate that exercise. In other words, they dictate the biological adaptation that we're going to develop.